Hello sa ating mga batang mandunong at home learning partners. Muli tayong nagbabalik sa ating Project SOAR para mag-aral at Math-tuto mula sa isa sa mga magagaling na guro ng City of Mandaluyong Science High School. He is a teacher too with CMSHS for 19 years. He is a graduate of Bachelor of Science in Secondary Education, major in Mathematics at Rizal Technological College. He also finished academic requirements for master's degree at National Teachers College. He's an MTAP scholar, an MTAP trainer, and currently a grade 9 math teacher. Our next lecturer for Project SOAR Week 9, Mr. Ricky F. Fabi.
Hello everyone, I am Ricky Fabic from the City of Mandaluyong Science High School, and I'm here to discuss to you how to solve problems involving radicals, an advanced lesson in grade 9 math for the second quarter, and this is in line with the Project SOAR series of online academic reviews of mathematics CLAID learning modules. So, Batang MANDunongs, let's get started and enjoy learning. Our today's objective is to solve problems involving radicals, and I do hope that after this session you can apply the knowledge that you'll be. In your previous lesson, you were engaged in solving radical equation, and you will be using this concept in solving worded ones. Let's review about a radical equation. A radical equation is an equation with one unknown or variable in the radicand or radix. And this is supported by the power rule for solving a radical equation, which states that if you raise two equal quantities to the same power, the results are equal quantities. And so if x and y are real numbers and x is equal to y, then x raised to the n power is equal to y raised to the n power. So it only means that if two numbers are equal and if you raise both of them to the same number, their sense of being equal is preserved. Let's go back with the rules in solving radical equations. Step number 1. Arrange the terms of the equation so that one term with radicals is by itself or on one side of the equation. This has something to do with isolating one radical on one side of the equation. Step number 2. Raise both sides of the equation to the index of the radical. Step number 3. If a radical still remains, repeat steps 1 and 2 and solve the variable. And of course, step number 4, we should not forget to check the answer in the original equation. Let's consider these radical equations. Let's solve. Number 1, 2 times the square root of x minus 3 equals 12. So as you noticed, both of them, I mean the left side of the equation and right side of the equation has the same, are sharing the same number, and both of them are divisible by this number, and that's 2. So all we have to do is to divide both sides by 2. So our new equation is square root of x minus 3 equals 6, and to get rid of the radical we have to square both sides. So we have x minus 3 is equal to 36, and that's obtained by raising 6 to the second power. To solve for x, just simply add 3 on both sides of the equation, that is by using the addition property of equality, and so our x is equal to 39. For us to really be sure that our answer is correct, we have to check. So go back with the original equation. 2 times the square root of x minus 3 equals 12. After that, just simply substitute or plug in x with 39, the one that we have obtained a while ago. And so we have 2 times the square root of 36 from 39 minus 3 is equal to 12. Getting the square root of 36, we obtain 6, and multiplying it by 2, and we have 12 is equal to 12. And so the solution is equal to 39. It means that 39 is the only number that satisfies the given radical equation. You can also express that using set. Problem number 2, or equation number 2. Fourth root of r plus 2 plus 6 is equal to 3. First step is to remove 6 at the left side of the equation so we can isolate the radical, which is fourth root of r plus 2. So what we did is subtract both sides of the equation by 6. So we have fourth root of r plus 2 equals negative 3, which is obtained upon subtracting 6 from 3. And so at this time we have to remove the radicals, and that is by raising both sides of the equation by 4. So the left side of the equation, radicals cancels out, so we have r plus 2, and at the right side the value of negative 3 to the fourth power is equal to 81. And to solve for r, just simply subtract 2 on both sides of the equation, and thus our value of r is equal to 79. Again, let us check. Let us prove that, or if 79 is really the solution of this particular equation. So go back with the original equation. Fourth root of r plus 2 plus 6 equals 3. Again, just plug in 79 to r. So we have fourth root of the square root of 79 plus 2, then plus 6 is equal to 3. Adding 79 and 2, we have 81. So our new equation is fourth root of 81 plus 6 is equal to 3. Now let's get the fourth root of 81, and that gives us 3. Then plus 6 is equal to 3. And 3 plus 6 is equal to 3 is false. So meaning there's no solution, or 79 did not satisfy the problem, or there exists the so-called extraneous root or extraneous solution. Example number 3. Solve for x. The square root of x plus 9 plus the square root of x minus 7 is equal to 8. All you have to do is to isolate one radical on one side of the equation, but it's your choice if you want the square root of x minus 7 to be at the left. But in my case, I prefer letting square root of x plus 9 to be at the left. So the new equation now is a square root of x plus 9 is equal to 8 minus the square root of x minus 7, and this time the square both sides. So what happens next? At the left, the radical sign cancels out, so we have x plus 9. On the right side, this is square of binomial. Remember that whenever we square a binomial, first we have to square the first term, and then the middle term should be twice the product of the first term and the second term, and then plus the square of the last term. So at the right side of the equation, we have a squared minus 2 times 8 times the square root of x minus 7 plus the quantity of the square root of x minus 7 squared. And then moving on, so in the meantime, just bring down x plus 9, and 8 squared is equal to 64, and this is the product of negative 2, 8, and square root of x minus 7 is negative 16 times x square root of x minus 7 plus, so the radical sign here cancels out, so we have plus x minus 7. And then we cancel out x. Cancelling out x here is just the same as adding both sides of the equation by x. And so we have, after simplifying all these terms in here, we'll end up with a new equation, a little bit simple one, unlike with the first one, which is 16 times the square root of x minus 7 is equal to 48. Now, notice that the left side of the equation and the right side of the equation share a common number. So I mean, 16 is the greatest common factor of 16 and 48. So I have to divide both sides of the equation by 16. So our new equation is the square root of x minus 7 is equal to 48. And for the last time, to finally remove or cancel out the radical sign, we have to square both sides. And so we have x minus 7 is equal to 9. And to solve for x is equal to 16. And again, to check if our answer is right, let's go back with the original equation, which is the square root of x plus 9 plus the square root of x minus 7 is equal to 8. So again, just simply plug in or substitute 16 to x, and it goes like this. So if we're going to add these two, 16 plus 9, and the right side subtract 7 from 16, so we'll be having square root of 25 plus the square root of 9 is equal to 8. And then getting their square roots, 25 and 9, so we have 5 plus 3 is equal to 8, and thus 8 is equal to 8. So again, it only shows that the only number that satisfies or makes the equation true is 16, and this will be our solution. Okay, at this time, let's try to solve problems involving radicals. We all know that many real-life problems can be solved by means of radical equation. To name a few, number-related problem, we have Pythagorean-related problems, we have area of a triangle problems, and we have the physics-related problems. Let's begin with number-related problems. Problem number 1. 4 times the square root of a number is 24. What is the number? So first step, we have to represent the unknown number. So in here, let x be the unknown number. Then translate the problem into mathematical phrase. So in this case, we'll be writing the working equation, and the expected working equation should be 4 times the square root of x is equal to 24. To simplify this one, just simply divide both sides of the equation by 4. And so we have square root and simplify. So we have square root of x is equal to 6. And to remove the radical sign here, square both sides. And so our answer is x is equal to 36 rather. And so let's verify if this x here, which is 36, really satisfies our problem. So again, checking, go back with your working equation, just substitute your variable x with 36, and then so we have 4 times the square root of 36 is 24. Getting the square root of 36, we have 6, and then times 4 is 24, and then 24 is equal to 24, meaning our answer is right, meaning the only number that satisfies this problem is 36. Problem number 2. The cube root of 1 less than 5 times a number is 4. what is the number? Again, represent the unknown number. So once again, let's assume, or let it be x be the unknown number, and then translate the problem into mathematical phrase or working equation. So we have cube root of 5x minus 1 is equal to 4. So in this case, for us to remove the radical sign or the radical, just simply raise both sides of the equation by 3. So what happens next? So at the left side of the equation, we have 5x minus 1, and in the right side, you have 64, and that was obtained by raising 4 to the third power. And then, to solve for x, just simply add both sides of the equation by 1. And so, negative 1 and 1 cancels out. And on the right side, 1 is being added to 64. So the new equation is 5x is equal to 65. And to finally solve for x, simply divide both sides of the equation by 5. And so, the value of x is equal to 13. So once again, let us verify if our answer is right. So go back with the equation. So cube root of 5x minus 1 is equal to 4. Again, just simply substitute the given variable x with 13. And so we have cube root of 5 times 13 minus 1 is equal to 4. Multiplying 5 and 13, we obtain 65. So we have cube root of 65 minus 1 equals 4. Subtracting 1 from 65, we have a difference of 64. So our new equation then is cube root of 64 equals 4. Getting the cube root of 64, you will get 4. And that's equal to 4 on the right side. And so, that's it. Let's try to solve Pythagorean problems. The problem is this. A woman bikes 6 kilometers to the east, going to school, and then walks 8 kilometers northward, going to the church. Now the question is, how far is she from the starting point, which is her house? So in math, it is really a must, or it is really a need to visualize the problem by drawing diagrams or illustration. So here it is. So there's a girl biking 6 kilometers to school, and then after that she walks 8 kilometers to the church. So our problem or our question here is, how far is she from the starting point? Where is her house? So we have here a triangle, and this triangle here is said to be a right triangle. So the unknown here is the distance, or the distance of the church to the house. And so let's work on. In problems like this, wherein right triangle is involved and two sides are given, we're using this kind of theorem, the Pythagorean theorem, which states that in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So if we're going to consider in here right triangle ACB, right angle at C, and the legs are represented by A and B. A is opposite angle A, and side B is opposite angle B, and the hypotenuse is opposite the right angle. So we have sides ABC, wherein the legs are A and B, and the hypotenuse is C. So the formula is A squared plus B squared is equal to C squared. So it's just simply squaring the legs, adding them, and it should be equal to square of the hypotenuse. If you're interested to solve for A, given that C and B are already given, so we can use the formula A is equal to the square root of C squared minus B squared. If you are interested to solve for B, you will use the formula B is equal to the square root of C squared minus A squared. And if you are also interested to solve for the hypotenuse, all you have to do is to use this formula. C is equal to A squared plus B squared. And so let's finish solving this problem. Okay, so for our solution, we have to represent the unknown number. So in this case, I let C as the distance from the house to the church, and that is the hypotenuse, no, in the right triangle. And of course, we should use the Pythagorean theorem because given the legs and one of the sides is unknown, and it's the hypotenuse in here. So the formula is C is equal to the square root of A squared plus B squared. Okay, substitute the lengths of the legs. So the legs are 6 and 8 respectively. So squaring them, so we obtained C is equal to the square root of 36 plus 64. Adding 36 and 64 inside the radical sign, we obtain 100. So C is equal to the square root of 100. Simplifying it, therefore C is equal to 10. Normally, we'll be obtaining here two values of C, the positive and the negative 10. But since we're dealing with distance problem, we'll just be getting the positive value because there's no such word as negative distance. So let's try to check. So therefore the woman is 10 kilometers from the house, or the church is 10 kilometers away from the house of the girl. And let's verify if our answer is right. So just simply go back with the equation. C is equal to the square root of A squared plus B squared. Just simply substitute A with 6, A with B with 2, and then getting their value. I mean squaring 6 and squaring 8. So 10 is equal to 100, and we all know that the square root of 100 is equal to 10, and thus they are said to be equal. So we can now finally conclude that the distance from the house to the church is 10 kilometers, or the church is 10 kilometers away from the house. Okay. This time, let's try to solve area of a triangle. So in the figure, we have a triangle ABC with sides 7 inches, 7 inches, and 2 inches. So the problem here is, what is the area of this triangle? Basically, the area of a triangle is solved by just simply multiplying the base and the height. No? But in this case, we don't have the height. We don't have a height in here, so we cannot apply the formula. But don't you know that there's a particular formula that helps us to solve the area of a triangle given the sides? That is the Heron's formula. The Heron's formula states that if the length of the three sides of a triangle are represented by A, B, and C, the area A and the semi-perimeter S of the triangle is given by the formula A, area, is equal to the square root of S times the difference of S minus A times the difference of S minus B and times the difference of S minus C. But we cannot just simply use that without the s. The s can be solved by simply adding a plus b plus c and dividing it by 2. Again, A is the area of the triangle, S is the semi-perimeter, and A, B, and C are the sides of the triangle. So let's try solving the area of this triangle ABC using the hero formula. So this is it. So solve the semi-perimeter first. So we'll be using the formula S is equal to A plus B plus C all over 2. And of course, we have to substitute the given lengths. So if we're going to assume that A is equal to 7, B is equal to 7, and C is equal to 2, so 7 plus 2 all over 2 is 16 all over 2 is equal to 8. So therefore, S is equal to 8. After you have computed for the semi-perimeter, and in our problem here, our 8 is the S. All we have to do next is just simply substitute the values of A, B, and C. No? So you all know that we assigned 7 for A, 7 for B, and then 2 for C. So this is it. So area is equal to the square root of 8 times 8 minus 7 times 8 minus 7, then times 8 minus 2. And so simplifying the terms inside the radical sign, so A is equal to 8 times 1 times 1 times 6, and so we have A is equal to 48. Now at this point we need to simplify the radicals. So to simplify square root of 48, just think of factors of 48 wherein one of them is a perfect square, and that is 16 and 3. No? So extracting the square root of 16, we have 4, and then just simply connect square root of 3. So therefore, the area of the triangle given the sides 7, 7, and 2 inches respectively is 4 times the square root of 3 square inches. Okay, let's try to solve physics-related problem. Now, the problem goes this way. If a ball is dropped on the ground from the height of h meter, then the ball reaches the ground with a velocity of 4.43 times the square root of h meter per second. Find the velocity with which the ball reaches the ground when it is dropped from a height of 64 meters. So this is the illustration. Okay. Now, of course, let's have the solution. So first we have to represent the unknown quantity, and let V be the velocity of the ball dropped from the height h meter in meter per second. Next, let's write the working equation. So it is V is equal to 4.43 times the square root of h, and all we have to do in this next step is to just simply substitute h with 64. Extracting the square root of 64, we obtain 8, and multiplying 8 by 4.43, therefore V, our velocity, is equal to 35.44. So again, the velocity of the ball that is dropped from the height of 64 meters is 35.44 meter per second. Check. Going back with the original equation, V is equal to 4.43 times the square root of h. Just simply substitute V with 35.44, and on the right side substitute h with 64, and extracting the square root of 64, we obtain 8, and multiplying 8 by 4.43, we obtained 35.44, and that is equated to 35.44 at the left, which is the velocity. Okay. Our last problem. The speed of the sound near Earth's surface can be found by the equation V is equal to 20 times the square root of T plus 273, where T is the outer temperature in degrees Celsius. Find the temperature if the speed of the sound is often given as 340 meters per second, or the MPS. Solution. Represent the unknown quantity. So let T be the temperature from a certain speed in degrees Celsius. Write the working equation. Our working equation is the one being given in the problem, and that is V is equal to 20 times the square root of T plus 273. Next, substitute the given value of V and simplify. So therefore V is equal to 340 is equal to 20 times the square root of T plus 273. If we're going to give a closer look with this equation, they are both divisible by 20. So let's do it. So divide both sides of the equation by 20. And the result is 17 is equal to the square root of T plus 273. And to solve for T, square both sides of the equation to eliminate the radical sign. And so we have obtained 289 is equal to T plus 273. Solving for T, we'll be getting a value which is equal to 16. So in other words, the temperature, if the speed of the sound near to the Earth, which is 340 meters per second, is 16 degrees Celsius. And so, that's all for today, and I hope that you learned something from me. But before I end up, may I share to you this quotation which I've read from a book that really inspires me. It goes this way: giving up is the most painful way of solving a problem. It means to say that whenever we encounter a problem, we should not turn our back, but rather face it with dignity, with courage and hope. Once again, thank you and God bless.